Welcome back to the deep dive, where we take these massive, often unseen engines of the modern world and really break them down into their most surprising, most important pieces.
It's always fascinating to peel back the layers on these companies that are just hiding in plain sight.
Absolutely. And today, we're talking about a company that is foundational to, well, virtually every modern industry. I mean, it's necessary for advanced manufacturing, it's critical for healthcare, it's the backbone of the food supply chain.
And yet, for most people, for most consumers, it flies completely below the radar. It is, I think, the ultimate definition of a hidden giant.
It really is.
When you think about the industrial supply chain, your mind probably goes to steel or, semiconductors, but you very rarely think about the specific gases that make all of those things possible. The scale of this operation is staggering.
And the history is incredible. The immediate surprise fact that we really want to ground this whole conversation in is this. We are diving deep into Air Products and Chemicals, Inc., an American multinational that, despite the kind of quiet name, has been mission-critical for the U.S. space program for 5 decades. We're talking about the company that supplied the very fuel that powered the space shuttle.
And that rocket fuel anecdote is, I think, the perfect lens for this. We're going to spend the next 30-plus minutes using this corporate profile and historical analysis we have to really understand the vast scale, the incredible history, and the often complex core business strategy of this S&P 500 component.
We've got a deep stack of sources today. Covers 85 years of history, leadership transitions, specific technical products, and some very recent, very strategic geopolitical shifts that just show how sensitive their business is to the global climate.
Yeah, that recent stuff is fascinating. But to set the stage, let's establish their profile immediately. The company is Air Products and Chemicals, Inc. It's a U.S.-based international corporation, and it specializes primarily in producing and selling industrial gases and, historically, certain chemicals.
And they are massive. We are talking about a major publicly traded entity on the New York Stock Exchange, ticker APD. Their corporate headquarters, which has been this stable fixture for decades, is located in Trexlertown, Pennsylvania.
Right in the heart of the manufacturing-intensive Lehigh Valley.
And when we talk about scale, we have to put those numbers on the table right at the beginning, just to give you some context for this whole discussion.
Please do.
Based on 2025 data, this company commands total assets of U.S. and ECS, $41.6 billion.
$51 billion, that's a huge number. And that's plants, equipment, supply infrastructure, all of it.
All of it. And they employ approximately 21,300 people worldwide, all managing this immense, complex logistical web that is dedicated almost entirely to things you can't see.
That's the perfect way to put it. They are literally turning the atmosphere into a commodity, into an indispensable industrial input.
So to understand how a company that's dedicated to something as, well, as ethereal as gas achieved this colossal scale, we have to travel back to the late 1930s, early 1940s.
Precisely. They are the infrastructure behind the infrastructure. And that whole idea started with a singular, brilliant strategic vision.
Okay, let's unpack this history, starting with the very foundation in 1940. Air Products was founded in Detroit by a visionary named Leonard Parker Poole.
Right. And his initial idea was, on the surface, simple, but it was incredibly disruptive, and it really defines their operational model even today.
So what was so disruptive?
Well, Poole recognized this fundamental inefficiency in the industrial gas market of the time. Back then, if a factory needed, say, a huge volume of oxygen for welding or steel production, what did they do?
I guess they'd have to buy it from some giant centralized plant, right?
Exactly. And then ship it, often over very long distances, in these large, heavy, dangerous vessels. It was inefficient, it was very costly, and it introduced some serious logistical risk. What if the truck was late? Your whole production line stops.
Okay, so what did Poole propose to fix that?
His initial objective was the specific goal of on-site production and sales of industrial gases.
So instead of shipping the product,
they would build a small, dedicated plant, a generator, right next to the customer's facility. They'd install it, operate it, maintain the equipment, and the customer would just pay for the gas flowing through the pipe. It was brilliant.
that solves the entire logistical headache. It eliminates those high transportation costs, and it ensures a continuous, reliable supply.
Yes, and that initial focus on customized, integrated on-site service is just a crucial detail for understanding the Air Products DNA. It wasn't about being the biggest plant, it was about being the most integrated partner.
But that focused industrial objective was about to be massively accelerated by global conflict.
Indeed, the ink was barely dry in the incorporation papers when, in 1941, the U.S. entered World War II.
And everything changed.
Everything. The need for specialized manufacturing just exploded, and Air Products, with its expertise in oxygen generation, found its trajectory instantly changed. They transformed, really overnight, from a niche industrial supplier into a critical military manufacturer.
This is where the story gets really compelling. It connects their early identity directly to the war effort. Air Products began manufacturing mobile generators designed specifically for the production of oxygen. And the demand was, as you can imagine, immediate and overwhelming.
And you have to think about high-altitude warfare during the 1940s. As aircraft technology advanced, bombers and fighters began operating at higher and higher elevations.
To avoid anti-aircraft fire and to take advantage of jet streams.
Exactly. But at those altitudes, the air pressure drops drastically, and pilots face hypoxia, a lack of oxygen to the brain. It's incredibly dangerous.
So the oxygen that was produced by these mobile generators, it wasn't for welding a tank on the battlefield. It was a matter of life and death for the airmen.
That's it, precisely. This oxygen was absolutely necessary for high-elevation military flights. These compact mobile generators were distributed globally to ensure that the U.S. Air Force and the Allied Air Forces in their war against Nazi Germany and the Axis powers had a reliable source of life support.
It was right there on the airfield, close to the front lines.
Right on the airfield. The company was essentially solving a massive, urgent operational bottleneck for the entire Allied air campaign. I mean, you can't run a high-altitude bombing campaign if your pilots are passing out.
The scale of that military contract must have been immense. So immense that the company's whole operational footprint had to dramatically shift just to keep up with production.
It did. The wartime focus on expanding oxygen production manufacturing capacity, it necessitated a physical relocation in 1944.
Away from Detroit.
Yes, they moved the entire operation and their headquarters from Detroit down to Chattanooga, Tennessee. And this move was purely pragmatic. It was all about leveraging specific resources or logistics pathways in the South that were necessary to scale up production capacity.
To meet that relentless military demand for these generators.
Relentless is the word.
But the shift to Chattanooga wasn't intended to be permanent, was it?
No, not at all. Following the conclusion of WWII, the company began a phased strategic return to Pennsylvania. They relocated their operations and headquarters initially to Emmaus, specifically drawn to the existing industrial and manufacturing density of the Lehigh Valley region.
Which, as you said, is in eastern Pennsylvania. Why there?
Well, the Lehigh Valley was, and it still is, an industrial hub. It provided the necessary access to skilled labor, to transport links, and, crucially, proximity to major customer markets in the Northeast and the Mid-Atlantic. This move was a deliberate step to stabilize the company post-war and get back to its core industrial customer base.
And the company eventually solidified its roots there.
Right.
The current corporate headquarters was developed and completed in the late 1950s in neighboring Trexlertown, Pennsylvania.
Yes, and it's an enormous complex that has really anchored their identity ever since.
And that decision has had a lasting regional economic impact, too. I mean, it's so easy to forget the local power of these global multinationals.
It really is. And our sources note that as of 2024, Air Products is cited as the 5th largest employer in the entire Lehigh Valley. That is a deep, entrenched regional history that was built directly on that foundation of wartime necessity and calculated industrial growth.
That's a powerful narrative thread. From a Detroit startup to an emergency wartime relocation in Tennessee to a permanent establishment as a major economic driver in Pennsylvania. It connects their historical resilience right back to their current global reality.
It does. It's a very American industrial story in that sense.
Now that we understand the origin, let's dive into Section 2 and address the core business. What exactly is a $41 billion company selling?
This is where we bridge that gap between their history and their essential role today. They established themselves as essential by mastering complex physical chemistry, and today that mastery serves an astonishing range of customer markets.
When you look at their service spectrum, the breadth is truly astonishing. Our sources list technology, energy, healthcare, food, and general industrial markets worldwide. If you are producing something, chances are you need one of their products.
Let's break that down with some tangible examples because, listing the sectors is one thing, but seeing the application really brings it to life.
Okay, go deeper. How does an industrial gas company impact my technology, for instance?
Great question. In the technology sector, particularly in semiconductor manufacturing, the purity of the environment is everything. Absolutely everything.
You mean inside the clean rooms where they make the chips?
Exactly. You need highly specialized gases to etch microscopic circuits onto silicon wafers or to grow crystals without any contamination. Even a single speck of dust can ruin a whole batch.
So what does Air Products do?
They supply the ultra-high purity nitrogen and specialty gases necessary to create what are called inert atmospheres inside those clean rooms. The nitrogen basically pushes out all the oxygen and moisture, protecting those delicate processes from any kind of reaction.
Okay, that makes sense. Now what about food? I wouldn't immediately connect an industrial gas supplier to my groceries.
Think about cryogenic freezing. Flash freezing food with ultra-cold liquid nitrogen locks in freshness and texture far better than traditional, slower freezing methods.
So, like frozen pizzas or berries.
Perfect example. Nitrogen is also used for what's called blanketing in food packaging. They pump nitrogen into a bag of potato chips, for instance, which displaces the oxygen.
And no oxygen means no spoilage. It extends the shelf life.
Precisely. So that bag of chips or that box of frozen berries you buy often owes its longevity directly to Air Products' nitrogen supply.
That's a great illustration of how essential these products are, even if they're invisible. So shifting to the core products, we can synthesize them into the category you mentioned earlier, atmospheric industrial gases.
Yes. They are literally processing the air we breathe and some other basic compounds and then selling them in various highly specialized forms. This includes the major players that anchor their business: oxygen, nitrogen, argon, hydrogen, and carbon dioxide.
It sounds simple when you list them like that, but the process is anything but. Can you briefly explain the necessity of, say, oxygen and nitrogen in heavy industry?
Sure. Let's start with nitrogen. Nitrogen is all about exclusion. It's an inert gas, which means it doesn't readily react with other substances.
So it's very stable.
Extremely. This makes it invaluable for safety. You can pump it into pipes or storage tanks to displace flammable vapors, which prevents explosions in chemical plants or refineries.
And in manufacturing.
It creates a pure, non-oxidizing atmosphere, which is essential for high-quality metal treatment and electronics production. You don't want your high-tech metals to rust or oxidize during production.
Okay, and what about oxygen? That's for combustion.
It's for efficiency. Adding pure oxygen to a combustion process like melting steel in a blast furnace doesn't just increase the heat, it dramatically increases the speed and efficiency of the chemical reaction.
So you get more bang for your buck, fuel-wise.
A lot more. It reduces fuel consumption, lowers operational costs for the customer, and can even reduce emissions. It transforms a slow, dirty process into a faster, cleaner one.
So it goes far beyond those basic atmospheric gases. Our sources highlight that they also deal in highly specific process and specialty gases, performance materials, and chemical intermediates.
And this is where they move from massive volume sales to high-margin specialized applications. This is where the really high-value products come in, integrating them into the core energy and chemical infrastructure of the world.
Like what?
For instance, they are enormous producers of refinery hydrogen.
Why is refinery hydrogen so crucial? I think most people associate hydrogen with, bombs or maybe fuel cells.
Well, modern environmental regulations demand cleaner fuels. Crude oil, as it comes out of the ground, contains a lot of sulfur and other contaminants.
The stuff that causes acid rain and pollution.
Exactly. Refineries use hydrogen in processes like hydrocracking and hydrotreating to chemically remove those contaminants. This process yields cleaner gasoline, diesel, and jet fuel.
So Air Products builds, owns, and operates the large-scale hydrogen production and supply infrastructure needed for these massive refineries. They're essentially making clean fuel possible.
That's a huge part of their business. They're also listed as major developers of liquefied natural gas or LNG technologies and equipment,
which places them right at the center of the global energy supply chain and a lot of geopolitical energy decisions.
It certainly does. LNG is just natural gas that's been cooled to minus 260 degrees Fahrenheit until it becomes a liquid. When it liquefies, its volume shrinks by 600 times, which makes it efficient to transport by ship across oceans.
And Air Products' role in that.
They design and build the massive, complex, cryogenic heat exchangers necessary for this liquefaction process. Their technology is literally the heart of an LNG facility. It's the specialized hardware that makes the global natural gas trade possible.
And we also see them in more traditional chemical applications, producing things like epoxy additives, advanced coatings, and adhesives. These are listed as chemical intermediates, which is a term we should probably define for you.
Yeah, that's a good idea. A chemical intermediate is a compound that's produced during one stage of a chemical synthesis that is then used as the raw material for the next stage.
So they're not the final product you buy in a store.
Right. They are components used to make the final product. For example, their epoxy additives might be sold to another company to manufacture high-performance industrial flooring or, composite aircraft parts. They're a key link in a very long chain.
And because many of these specialty gases, like the ones used in electronics or pharmaceuticals, are highly toxic or reactive or just dangerous, the company also provides the necessary manufacturing hardware, specifically the provision of gas cabinets.
Right. And a gas cabinet is far more than a simple storage locker. It's a precisely engineered containment system. It's designed to house gas cylinders under strict flow and safety control.
Safety device.
A very sophisticated one. They ensure that toxic specialty gases are delivered to the process tool safely, preventing leaks, managing the high pressures involved. It just underscores their role as a comprehensive solutions provider, not just a gas vendor.
That is immense breadth, from refinery inputs and LNG technology all the way down to safety containment hardware. But, as we mentioned earlier, if you want the ultimate high-tech application that binds their past to their present, you have to look up, straight to space.
This is the historical through line. This is what connects those mobile oxygen generators of WWII to modern rocketry. Our sources detail a long-standing, deep working relationship with NASA that spans 5 decades.
I mean, just think about the immense trust that is placed in a supplier when the product is the literal engine of human space exploration.
It's a mission-critical collaboration built on decades of impeccable reliability. Air Products supplied the liquid hydrogen LH2 and the liquid oxygen LOX fuel used for every single space shuttle external tank launch.
And those are the most powerful cryogenic propellants available, right?
They are. They're also incredibly difficult and dangerous to handle because of their extremely cold temperatures. We're talking hundreds of degrees below zero.
The precision required to produce, store, and then deliver these cryogenic propellants must be beyond staggering. There's just zero margin for error in the final product.
Zero. Any impurity could cause a catastrophic failure. And that immense legacy, it doesn't just start with the space shuttle program.
No, the relationship traces back much further.
It does. They provided liquid hydrogen for the earlier Mercury and Apollo missions as well. So from the earliest human spaceflight efforts in the 1960s right up through the end of the space shuttle program in 2011, this one company was providing the literal propulsion.
It just solidifies their status as masters of cryogenic chemistry.
That is the ultimate proof of expertise. You are not getting that contract without proving absolute mastery over gas purity and handling.
And speaking of demanding technological challenges, that level of rigor leads us seamlessly into Section 3, where we discuss their impact on fundamental science and their groundbreaking environmental contributions.
It's fascinating, isn't it, that the same rigor required to safely launch a rocket is also applied to redefine universal physical constants.
Okay, let's talk about the scientific contribution, because this is truly one of the most surprising aha moments in our source material. In 2013, one of their specific products was utilized to help determine a more accurate value for the Boltzmann constant.
This is a detail that just sticks with you. To understand why this matters, we have to talk about what the Boltzmann constant even is. It's often denoted as K.
Right, it's a fundamental constant of physics.
It is. It relates the average kinetic energy of particles in a gas to the temperature of that gas. Essentially, it's the bridge between the microscopic world of atoms and the macroscopic world of thermodynamics and observable temperature.
So refining its value has massive implications across all of physics, and especially in the field of metrology, which is the science of measurement. Why would an industrial gas company be involved in refining this constant?
The specific product used was the company's high-purity built-in purifier argon. To measure the Boltzmann constant with unprecedented precision, scientists rely on something called acoustic gas thermometry.
Which is exactly.
They measure the speed of sound in a monatomic gas-like argon at various temperatures to infer the thermal properties of the gas. The speed of sound is directly related to the movement of the atoms, which is related to the temperature through the Boltzmann constant.
And the requirement for purity.
It must be virtually flawless.
Ah.
Any contamination, Even trace amounts of other gases like water vapor or nitrogen would introduce minute molecular interference. It would cause the pressure and volume readings to be inaccurate, throwing off the whole calculation.
So Air Products specialized argon, which was processed using their proprietary built-in purifier technology, achieved the necessary level of near absolute purity to eliminate these variables.
It provided the reliable medium needed for the definitive measurement.
That's such a powerful connection. The ability to strip contaminants from the atmosphere, perfected through decades of industrial supply, applied directly to advancing fundamental human knowledge. It just confirms their status as a specialized technology powerhouse.
Absolutely. The rigor required for that level of purity is their signature expertise. And they have also applied that intense rigor to their own operations, particularly regarding sustainability and corporate responsibility in the 21st century.
Their track record here is substantiated by concrete metrics, not just, lofty goals. Let's look at their water conservation success recognized all the way back in 2001. They received an Award of Merit from the Water Use Association for outstanding water conservation efforts.
And this is not a small symbolic gesture. We have the specific metrics that make this achievement quantifiable and highly impactful. Their conservation efforts involved converting their water source for the cooling process at their Santa Clara, California facility.
And what was the key change they made?
They converted to using recycled water instead of potable drinking quality water. Cooling processes in industrial facilities are notoriously thirsty. They use a huge amount of water.
So by making the switch,
they achieved annual savings of 62 million U.S. gallons. That's over 230,000 cubic meters of drinking water annually.
62 million gallons annually from a single facility's cooling system. That demonstrates real operational change and a real commitment to reducing their footprint in a high-demand, arid region like Santa Clara.
It goes far beyond simply adhering to minimum regulatory standards.
It does. And furthermore, they have consistently been recognized for their broader climate and carbon management strategies. They were named to the prestigious Dow Jones Sustainability North America Index for 4 consecutive years, from 2008 to 2011.
And being on that index is a big deal. It placed them among the top tier of companies globally for economic, environmental, and social performance during that time.
And recognition also came from groups like Maplecroft. In 2004, they were named a Maplecroft Climate Innovation Indexes, or CIIs, leader. That evaluation placed them as the 17th largest U.S.-based company specifically for climate-related innovation and for having robust carbon management programs.
It's important to understand what carbon management means for a gas company. It involves optimizing their massive energy consumption, implementing energy-efficient production technologies, and actively seeking to capture or reuse CO2 that might otherwise be vented into the atmosphere.
And this historical focus is clearly driving their current investments. The source material confirms their active involvement in several preeminent carbon capture and storage demonstration projects around the world today.
They are leveraging their core expertise in gas separation and handling directly into climate solutions for heavy industry. It's a natural evolution. A company that separates nitrogen from oxygen in the atmosphere can certainly separate CO2 from industrial effluent.
They also demonstrated remarkable foresight regarding hydrogen as a clean fuel source. Back in 2010, they won the Rushlight Hydrogen and Fuel Cells Industry Award for their Series 10 hydrogen fueling station.
This award specifically recognized their work in the UK and Ireland for its role in reducing carbon emissions. And this isn't just a lab project. This was a deployable commercial solution for hydrogen infrastructure over a decade ago. It showcases their early commitment to the hydrogen economy long before it became a global government priority.
And to wrap up this section on their corporate identity, they were recognized more broadly in 2010 by being included in Corporate Responsibility Magazine's 100 Best Corporate Citizens list.
Which highlights that their focus extends beyond just environmental metrics and into broader social and governance areas as well.
So we have a clear picture. A company built on wartime necessity, anchored by technological mastery in cryogenics and purity, and operating as a responsible, forward-thinking corporate citizen for decades.
And that sets the stage perfectly for Section 4, which deals with the modern company, the intense strategic transformation, the geopolitical pivots, and the startling recent financial results. This is where we see the immense pressure of corporate realignment and global instability.
This modern era is really defined by a philosophical shift. A profound strategic decision made by the leadership to narrow the company's focus almost exclusively back to core industrial gases. It was a move to simplify and sharpen the business model.
It was.
Let's explore the rationale behind this divestiture philosophy. Before the major spin-offs, Air Products was a much broader conglomerate. Why did management feel the need to shed what were profitable divisions?
This ties back to what investors often call the conglomerate discount. When a company operates disparate businesses, industrial gases, specialty chemicals, materials technologies, the market often struggles to value it accurately.
So the stock price doesn't reflect the sum of its parts.
Exactly. Investors, especially in recent years, prefer focus. They want to know exactly what they're buying. The previous leadership under Seifi Ghasemi aimed to unlock shareholder value by creating a pure-play industrial gas giant.
So let's detail that massive restructuring, starting with the spin-off. The intent to spin off the materials technologies business was announced in 2015.
Right. And the result was the creation of a brand new, standalone, publicly traded company named Versum Materials. The spinoff was completed on October 3, 2016.
And what did Versum do?
Versum was specifically focused on high-purity chemicals and materials for the semiconductor and electronics industries. A highly technical and profitable niche, but one that didn't fit that new pure gas strategy.
And the decision proved sound for Versum, right? Because they found a perfect, high-value home in a different sector shortly after.
They did, very quickly. Versum was later acquired by the major pharmaceutical and science company Merck. This separation allowed that specific business unit to find its ultimate high-value home in a related science sector. It really validated the idea that the business was better off standing alone.
But the divestiture didn't stop with Versum. In January 2017, they completed the sale of the Performance Materials division to Evonik, a major German specialty chemicals company.
This was the second, equally defining sale in quick succession. Performance Materials focused on areas like advanced coatings, adhesives, and specialty additives.
So after these two massive sales, what was left?
The company was left focused squarely and purely on its industrial gases business, the production, delivery, and application of oxygen, nitrogen, hydrogen, argon, and all the associated equipment.
This strategic shift placed them in a highly focused, capital-intensive position, just as the world entered a period of extreme geopolitical volatility. And that forced them to navigate some significant economic headwinds starting in 2022.
The first major headwind was the Russia divestiture following the 2022 invasion of Ukraine. And this is an action that we have to report on impartially, relying strictly on the documentation of corporate actions.
Right. Initially, when international sanctions were levied against Russia, the company took the position of continuing its operations in the country. And that stance attracted considerable attention during a period when many multinationals were rapidly exiting the market.
It did. However, the source material confirms that, likely due to mounting operational, legal, or reputational pressure, they reversed that position. According to data tracked by the Yale School of Management, which details corporate responses to the conflict, Air Products has since fully divested its interests in Russia.
And unwinding operations in a major complex market like Russia has to be a massive logistical and financial challenge for a company that relies on fixed assets and long-term contracts.
Oh, it's immense. It just highlights how swiftly global events can force a multinational corporation to adjust its operational footprint, even at an immense cost.
And that wasn't the only high-profile withdrawal they've had recently, which demonstrates the complexity of navigating public policy. We also have the case of the UK green hydrogen project.
A much more recent strategic pullback dating to 2025.
And this was a commitment that fit perfectly with their historical sustainability goals and their long history of hydrogen fueling innovation. In 2022, Air Products had announced these ambitious plans for the development of a major green hydrogen production plant in the Humberside region of the United Kingdom.
This was intended to be a flagship project, a massive commitment to decarbonization in a key industrial region of the UK.
But then, in June 2025, the company pulled the plug.
They did. They withdrew their involvement and their investment entirely. And given their decades-long dedication to hydrogen, this was a staggering decision.
The significance of this withdrawal, I think, lies in the specific reason given in our source material. They cited a lack of commitment by the British government.
And that phrase is highly instructive. It tells you so much about the challenges of the energy transition.
What does it tell you?
Well, when a company like Air Products commits to a multi-billion-dollar green hydrogen facility, they are taking on enormous capital risk. They need certainty regarding future demand, pricing, and operational support from the government.
So what would a lack of commitment likely mean in this context?
It suggests a few possibilities, none of which are good for massive long-term investors. It could mean insufficient progress on regulatory frameworks, a lack of firm government power purchase agreements.
Which are essentially guaranteed buyers for the high-cost green hydrogen.
Exactly. Or uncertainties surrounding subsidies, which are necessary to make green hydrogen competitive with cheaper fossil fuel-derived alternatives. It signals that even the biggest players won't commit billions if the foundational policy framework is perceived as unstable or insufficient to de-risk the investment.
That really sets the high-stakes backdrop for the current corporate landscape. So let's provide a quick overview of the corporate leadership that guided them through these 85 years of shifts, from wartime scaling to massive spinoffs.
The company has seen periods of remarkable stability. Leonard Poole, the founder, obviously holds the longest tenure, leading the company from 1940 until 1973. That's a 33-year run defining the foundational structure.
And following Poole, there was a steady stream of leadership, including names like Ed Donnelly, Dexter Baker, Hap Wagner, J.P. Jones, and John McGlade.
The recent transitions, however, are particularly important for understanding the strategic realignment we just discussed. Seifi Ghasemi took the helm in 2014, and he was the architect of that pure-play industrial gas strategy. He guided the company through the spin-offs of Versum and the sale to Evonik. He led until 2025.
And the current CEO, taking over in 2025, is Eduardo F. Menezes, stepping into the role of a highly focused industrial giant. And we should note that Wayne T. Smith, who played a role in that leadership transition, remains as chairman.
Which ensures institutional knowledge is retained during this period of intense focus.
This focused, highly capitalized company brings us to our final and perhaps most interesting segment of the deep dive, the 2025 financial figures. This is where we see the costs of the transition laid bare.
It really is a financial paradox.
On the top line, the revenue in 2025 was US $12.4 billion. That is a colossal revenue stream, confirming their continued dominance in the industrial gas sector.
That revenue confirms the operational strength of the pure-play gas business, no question. However, the 2025 bottom-line figures are striking, and this is where the context becomes absolutely crucial for you. We see significant negative figures recorded in key income areas.
Specifically, the operating income for 2025 was a negative $877 million. And the net income, the actual profit figure, was negative $395 million. Those are huge losses for a company that is fundamentally healthy.
This is a critical moment for financial learners because these figures do not mean the business suddenly stopped making money on its gas sales. That's not what's happening.
It is happening.
When a company executes a major strategic realignment, the accounting for those divestitures and geopolitical shifts like the Russia pullout can generate massive one-time non-cash charges.
Can you give us an analogy to explain why they lost almost $900 million in operating income while bringing in $12 billion in revenue?
Sure. Think of it like a family that sells off two major long-held assets, say a separate vacation property and a side business. Even if those assets were valuable, when you sell them, you might have to take the immediate hit for all the accumulated costs of separation, legal fees, impairment charges, and non-cash write-downs in that specific tax year.
You're clearing the balance sheet.
You're clearing the balance sheet. For Air Products, the costs associated with shuttering or selling assets in Russia, combined with potentially large impairment charges related to the UK hydrogen withdrawal, are often recorded as enormous expenses on the income statement.
Impairment charges are key here, right?
Yes. An impairment charge is simply recognizing that an asset you own, like a plant in Russia or early infrastructure costs in the UK, is now worth less than the value you carried it for on your books.
Because you decided to exit the market?
Precisely. You have to write down that loss immediately, even if it's not cash going out the door today. It makes the profit and loss statement look awful for a year, but it's a structural cleanup.
And we can confirm that this is a temporary structural anomaly, not a sign of imminent crisis when we look at their equity position.
Absolutely. Despite those huge negative income figures, the total equity, which represents the underlying value of the assets owned by the shareholders, remains substantially positive at $15.2 billion.
And that $15 billion provides the necessary financial buffer to absorb those hundreds of millions in transitional costs and losses.
It confirms the underlying strength and asset base of the newly focused company.
So the final data point we leave you with is a picture of a company that has successfully achieved its pure play vision. But 2025 was the year they paid the steep, immediate financial price for that strategic realignment and for navigating global instability.
Focused, immensely valuable in terms of assets, but dealing with the complex, costly reality of being a massive global player in a volatile world.
So let's synthesize this deep dive. We've covered a remarkable trajectory. From Leonard Parker Poole's foundational idea of on-site production in Detroit, accelerated by manufacturing mobile oxygen generators during WWII, to fueling the Mercury, Apollo, and Space Shuttle programs.
We saw how that commitment to purity extends from rocket science down into fundamental physics, with their high-purity argon contributing to the refinement of the Boltzmann constant, and how that translates into concrete environmental achievements, like conserving 62 million gallons of drinking water annually.
The key insight in the modern era is how corporate identity can shift so dramatically. The journey from a sprawling, diverse chemicals and materials company, with divisions later sold to Merck and Evonik, to a purely focused industrial gas giant was complex, expensive, and driven by a philosophical desire to unlock shareholder value through singularity of purpose.
We've given you the key facts. The $41 billion scale, the specific, high-tech products, the decades of dedication to hydrogen, and the corporate decisions that make this company a hidden giant of global industry, essential to everything from semiconductor manufacturing to food preservation.
You now have the shortcut to understanding Air Products.
And that brings us to our final provocative thought for you to consider as you wrap up this deep dive. We saw that Air Products has a deep, demonstrable commitment to sustainability, carbon management, and hydrogen innovation.
So, what does the sudden and highly public withdrawal from a massive green hydrogen project in the UK, a project perfectly aligned with their stated goals, citing a lack of commitment from a national government, what does that truly imply about the current state of global energy transition?
It raises a vital question, I think, about the complex intersection of private investment and public policy. Does the withdrawal signal that governments need to de-risk these massive, first-of-a-kind energy transition projects?
Maybe through guaranteed offtake contracts or stronger subsidies to attract the necessary industrial giants who possess the technology and the capital.
Or does it highlight that even the most committed corporate climate pledges can be abandoned when the financial uncertainty surrounding regulatory stability just becomes too high? It's a tension between political will and private capital that will define the success or failure of decarbonization efforts worldwide.
It's something well worth mulling over. Thank you for diving deep with us today.
Until next time.